Hello students, in today's video I am going to discuss the concept of mean and variance of the binomial distribution of the binomial distribution. So students, before starting this topic we must know what is the probability mass function of binomial distribution, that is PMF. Probability mass function means PMF, that is equal to fx ncx p to the power x q to the power n minus x, and where x is from 0 up to n. Now in order to find the mean of binomial distribution, we must know that mean is equal to expectation of x, that is summation x is 0 to n x into associated probability mass function, which is equal to summation x equal to 0 to n x into, and what is the value of fx? It is like this: ncx p to the power x q to the power n minus x. So here I can utilize the formula. The formula I am talking about is the formula of this ncx, that is factorial n upon factorial x into factorial n minus x, that is p to the power x in multiplication and q to the power n minus x. Now thereafter I can utilize the formula factorial n is n factorial n minus 1 and factorial x is x factorial x minus 1. So it will be summation x into n into factorial n minus 1 upon x into factorial x minus 1 and factorial n minus x and p to the power x and q to the power n minus x. Since it is starting from factorial x minus 1, now I mean to say since factorial x minus 1 is there, so now this loop will be, summation will be starting from x equal to 1. So this x and x will be cancelled out, and here I will multiply with p and divide by p in order to make a formula. So this n p is outside of the summation now, that is summation x equal to 1 to n and factorial n minus 1 upon factorial x minus 1, and this can be written like factorial n minus 1 minus x minus 1, and this p power x upon this is ultimately p to the power x minus 1, and this may be written like q to the power n minus 1 minus x minus 1. So students, what is this term? All of us are aware of that. It is np into summation x is 1 to n. This term is actually n minus 1 c x minus 1, and in multiplication p to the power x minus 1 and into q to the power n minus 1 minus x minus 1 is given. So how we can write this whole term? This whole term can be written like q plus p whole power n minus 1. So np, and this q plus p is ultimately 1 to the power is whole power n minus 1 is given. So that is np into 1, that is ultimately it is np. So this is the students final value of the mean of binomial distribution. Now thereafter we can go towards the variance of binomial distribution, and we know what is the basic formula of variance, that is expectation of x square minus expectation of x whole square. So now this term, this value we are already having, and we need to evaluate first of all this value. So I am talking about this value, I mean to say expectation of x square, that is summation x equal to 0 to n x square into associated probability mass function, that is summation x equal to 0 to n x square into, and fx is what here? ncx p to the power x q to the power n minus x. So again the thing is like, we will just expand the formula here of ncx, that is factorial n upon factorial x into factorial n minus x p to the power x q to the power n minus x, and here factorial n I will write like n minus 1 factorial n minus 2, factorial x is like x minus 1 factorial x minus 2. So it would be like summation x is, okay, before this one more change I will do here, one more modification, and that modification is summation. Suppose I'm just removing this particular step here, so that summation, that particular modification is required here in order to simplify the calculation process. And what is that process? Summation x equal to 0 to n, this x square I can write like x minus 1 plus x, yeah, that is right, into ncx p to the power x q to the power n minus x. Now we can split this summation in with these two terms, so that would be summation x equal to 0 to n x minus 1 ncx p to the power x q power n minus x plus summation x is 0 to n x into ncx p power x q power n minus x. Yes, this term is actually mean, and mean is here equal to np, so this whole term is simplified as mean. So that is why this particular modification is done here. So it would be like summation x equal to 0 to n x minus 1 ncx p to the power x q to the power n minus x plus np. So now students, thereafter we will just expand this value of ncx, so that would be summation x is 0 to n x minus 1 factorial n upon factorial x factorial n minus x and p power x q power n minus x and plus np. So now these formula we are going to incorporate here. So this will be summation, and here x minus 1 n minus 1 factorial n minus 2 upon x minus 1 factorial x minus 2 factorial n minus x and p to the power x q to the power n minus x plus np. So students, since factorial x minus 2 is provided here, so this summation will be starting from x equal to 2 now. So as we know, this term and this term will be cancelled out, and this nn minus 1 I can take before summation. So nn minus 1 summation x is equal to 2 to n factorial n minus 2 upon factorial x minus 2 upon n into factorial n minus x, and I will multiply here with p square and divide here by p square. So this p square I can take before summation, and this upon this term is actually p to the power x minus 2 and q to the power n minus x plus np. So students, little bit more modification is required here. Nn minus 1 p square and summation x is 2 to n factorial n minus 2 upon factorial x minus 2. This may be written like factorial n minus 2 minus x minus 2 into p to the power x minus 2, and here q to the power n minus 2 minus x minus 2. Yes, that's it, and plus np. So how it can be simplified now? It may be written like n minus 1 p square summation x is 2 to n, and that is n minus 2 c x minus 2, this whole term is actually, and into p to the power x minus 2 q to the power n minus 2 minus x minus 2 and plus np. So now students, this whole term is treated like q plus p whole power n minus 2. So that is n minus 1 p square and q plus p whole power n minus 2, and it is plus np. And we know how to tackle this term, that is nn minus 1 p square, q plus p is 1, so 1 to the power n minus 2 is ultimately 1, so plus np is here. So this is students expectation of x square. Now we are having all the required values, so we can easily implement these values here in the formula of variance. Variance is expectation x square minus expectation of x whole square. So what is expectation of x square? That is this particular value nn minus 1 p square plus np, and minus expectation of x here in the binomial distribution is np, so it's whole square. So that is n square p square minus np square plus np minus n square p square. So this and this will be cancelled out, that is np minus np square, np is outside, 1 minus p is here, that is npq. So students, we have obtained in this particular video that mean of the binomial distribution is np and the variance of the binomial distribution is NPQ. I hope students this particular video will help you a lot in order to understand the concept of mean and variance for discrete distribution. Thank you so much for watching this video.